So in May 2024, something happened that most people either missed completely or saw as a cool aurora photo on their Instagram feed and kept scrolling. And I get it, the auroras were beautiful. People were sending those photos to everyone they knew. Strangers were texting each other at midnight saying, "Go outside right now." Everyone was sharing them, reposting them, and almost nobody had any idea what was actually happening while they were doing it. Nobody in those comment sections was talking about satellites falling out of orbit. Nobody was talking about farmers in 12 states who could not plant their crops. Everyone just saw the pretty lights and moved on. But here is what was actually happening behind those photos. A sunspot 17 times the size of Earth had just fired a wall of magnetized plasma at us at 800 kilometers per second. Satellites were being pushed out of orbit, and a farmer in Illinois, just a regular farmer trying to plant corn during spring, lost somewhere between $12,000 and $17,000 that week because of that sunspot, because of something 93 million miles away that he probably did not even know was happening, while he was standing next to a tractor that suddenly would not work properly. I think about that image a lot. The sun reached into a cornfield in the American Midwest, and the farmer had no idea the two things were even connected, and none of it was supposed to happen. A room full of the world's best solar scientists had looked at the sun 5 years earlier, and they said this was going to be a quiet decade. That is what this video is actually about. Long before anyone took an aurora selfie with their phone, people were tracking the sun's moods with nothing but a telescope and a notebook. The official sunspot record stretches all the way back to 1755, when astronomers first started counting those dark, shifting patches on the sun's surface. Every 11 years or so, the count rises and falls in a rhythm as steady as a heartbeat. It is a cycle that shapes everything from radio signals to the color of the northern sky. Scientists call this the solar cycle, and it has been the backbone of space weather forecasting for centuries. The last cycle, solar cycle 24, was unusually quiet. At its peak in 2014, the average monthly sunspot number barely reached 116. For comparison, some earlier cycles topped 200. That stretch of calm became the new normal. When cycle 24 faded out, researchers looked at the data and saw a sun that seemed to be winding down, almost like a clock losing its spring. That's why in 2019 the world's top solar scientists gathered and agreed the next cycle would be just as mild, maybe even quieter. They were not guessing, these were models built on centuries of data, all pointing to a sleepy sun. Nobody in that room was talking about satellites falling out of the sky, or a farmer's tractor losing its GPS in the middle of planting season. The numbers were supposed to keep the world safe from surprises, but as it turns out, the sun does not always read the forecast. In April 2019, the world's top solar scientists gathered around a table. NASA, NOAA, the International Space Environment Service, and a dozen of the best minds in solar physics. Their task was simple: predict the sun's next move. The result was a single, carefully crafted number: 115. That was the official forecast for the peak smoothed sunspot number of solar cycle 25. Not a wild guess, but the outcome of 50 different models and decades of sunspot records, all averaged and debated until the panel could stand behind one figure. The forecast called for a mild, below-average cycle, a repeat of the quiet years just past. The press release spelled it out. Cycle 25 was expected to peak at 115 sunspots, maybe as low as 105 or as high as 125, sometime between November 2024 and March 2026. The message was calm, even reassuring. The panel's job was not to chase headlines, but to give satellite operators, power grid managers, and everyday people a sense of certainty. A number like 115 meant business as usual, no reason to panic, No reason to expect the kind of storms that knock satellites out of orbit or scramble GPS signals in the middle of a cornfield. I remember sitting with that forecast, looking at the neat curve on the chart, and thinking this is the best the science can do. The sun, they said, would be quiet. But the sun had other ideas. The numbers told a different story than anyone expected. By October 2024, the official sunspot count, the smoothed value tracked by the SILSO database, hit 161. That is not just a little higher than the forecast. That is 46% above the 2019 consensus. A leap outside the error bars that was supposed to keep us safe from surprises. The forecast panel, with all its models and expert judgment, had settled on 115 as the best guess for the peak. Their confidence interval stretched only from 105 to 125, and even the most optimistic scenarios did not reach the levels now recorded. The timing was off too. The forecast called for a peak in July 2025, give or take 8 months. Instead, the sun reached its maximum in October 2024, nearly 9 months ahead of schedule. Looking at the chart, the observed curve does not just nudge past the prediction, it rockets above it, shattering the upper boundary of the confidence envelope. For decades, cycle forecasts had missed by maybe 15%, sometimes a bit more. But nothing like this. The last time a forecast was this far off, we did not have satellites in orbit or GPS guiding tractors in Illinois. Now, every percentage point matters. A 46% gap means more solar storms, more atmospheric heating, more drag on satellites, and more days when a farmer's tractor just sits, waiting for the signal to come back. The sun, it seems, had its own agenda, and the world's best models were left playing catch-up. In May 2024, the sun delivered a spectacle that no one in mission control could ignore. At the heart of the drama was active region 3664, a sunspot cluster so massive you could line up 15 Earths across its face and still have room to spare. Its tangled magnetic fields, classified as beta, gamma, delta, stored energy like a loaded spring. Over 10 days, active region 3664 unleashed 5 X-class flares, each one a burst of radiation strong enough to disrupt radio on the day side of Earth. But the real trouble started when a series of coronal mass ejections, each moving at 1,700 kilometers per second, collided and merged into a single dense shockwave, a so-called cannibal coronal mass ejection. When that plasma wall slammed into Earth on May 10th, the planet's magnetic field reeled. The KP index, which tracks geomagnetic disturbance, hit 9, the highest possible value. Auroras spilled south past Texas and into northern China, lighting up social media with images. But while the world watched the sky, satellite operators watched their telemetry screens in growing alarm. The storm heated the upper atmosphere, causing it to swell and thicken. Satellites in low Earth orbit, especially the Starlink fleet, were suddenly ploughing through denser air. Drag spiked overnight, and by June, SpaceX had tracked the loss or decay of roughly 316 satellites, an entire layer of the network forced down early by the sun's unexpected violence. For every aurora photo, there was a mission controller somewhere running calculations and watching fuel margins shrink. The sun's outburst was not just a light show, it was a billion-dollar stress test for the technology orbiting above our heads, and a warning that the sun's surprises do not end at the edge of space. In central Illinois, a corn farmer started his morning like any other in May. Tractor-fueled, rows mapped out, everything riding on the promise of precision. But when he fired up the RTK GPS, the screen blinked and froze, no signal. The ionosphere above the Midwest had turned turbulent, twisting satellite signals into static. For 12 hours, his tractor sat idle, while the planting window narrowed and the cost meter ticked upward. By dusk, he was staring at a ledger showing $12,000, maybe $17,000. Gone to downtime, fuel, and missed opportunity. The numbers on his spreadsheet were as real as any storm cloud. Out in the field, it was not the aurora that mattered. It was the silence of a machine waiting for a signal that would not come. For years, forecasts treated the sun's 11-year sunspot cycle as routine, missing the deeper influence of the 22-year Hale magnetic cycle. Dr. Scott McIntosh and his NCAR team challenged this view, focusing on the Terminator event, when the sun's old magnetic cycle cancels at the equator. Their model predicted a cycle 25 peak near 190 sunspots, far above the consensus of 115. History supports their caution. The Carrington event in 1859, Quebec's blackout in 1989, and the 2003 Halloween storms all struck when traditional models failed to see the signs. Ignoring these deeper cycles leaves our technology and economy exposed as the sun's hidden rhythms continue to shape risk. We watch the forecasts, then watch the sun rewrite them. The real cost landed on a farmer's balance sheet, not a NASA chart. As solar cycle 26 approaches, the stakes get personal. Our models shape the world we prepare for. The sun does not care, but we have to.